All right, so today's story time from our big ol' What If book is what would happen if you were to gather a mole, unit of measurement of moles, the small furry critter, in one place? Well, the answer is that things get a bit gruesome. So first, some definitions. A mole is a unit. It's not a typical unit though. It's really just a number, like a dozen or a billion. If you have a mole of something, it means you have 602 blah 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 number of them, usually written 6.022 times 10 to the 23rd. It's such a big number because it's used for counting numbers of molecules, which there are a lot of. A mole is also a type of burrowing mammal. There are a handful of types of moles, and some of them are truly horrifying. So what would a mole of moles, or animals, look like? First, let's start with wild approximations. This is an example of what might go through my head before I even pick up a calculator when I'm trying to get a sense of the quantities. The kind of calculation where 10, 1, and 0.1 are all close enough that we can consider them equal. A mole, the animal, is small enough for me to pick up and throw. Anything I can throw weighs 1 pound. 1 pound is 1 kilogram. The number 6.022 times 10 to the 23rd looks about twice as long as a trillion, which means it's about a trillion. I happen to remember that a trillion kilograms is how much a planet weighs. That's enough to tell us that we're talking about a pile of moles on the scale of a planet. It's a pretty rough estimate, since it could be off by a factor of thousands in either direction. So let's get some better numbers. An eastern mole weighs about 75 grams, which means a mole of moles weighs 6.022 times 10 to the 23rd times 75 grams, or about 4.52 times 10 to the 22 kilograms. That's a little over half the mass of our moon. Mammals are largely water. A kilogram of water takes up a liter of volume. So if the moles weigh 4.52 times 10 to the 22 kilograms, they take up about 4.52 times 10 to the 22 liters of volume. You might notice that we're ignoring the pockets of space between the moles, and in a moment you'll see why. The cubed root of 4.52 times 10 to the 22 liters is 3,562 kilometers, which means we're talking about a sphere with a radius of 2,210 kilometers, or a cube 2,213 miles on each edge. If these moles were released onto the Earth's surface, they'd fill it up to 80 kilometers deep. That's just about to the former edge of space. This smothering ocean of high-pressure meat would wipe out most life on the planet, which could, to Reddit's horror, threaten the integrity of the DNS system. So doing this on Earth is definitely not an option. So instead, let's gather the moles in an interplanetary space. Gravitational attraction would pull them into a sphere. Meat doesn't compress very well, so it would undergo a little bit of gravitational contraction, and we'd end up with a mole planet slightly larger than the moon. The moles would have surface gravity of about 1/16 of Earth's, similar to that of Pluto. The planet would start off uniformly lukewarm, probably a bit over room temperature, and the gravitational contraction would heat the deep interior by a handful of degrees. But this is where it gets weird. The whole planet would be a giant sphere of meat. It would have a lot of latent energy. There are enough calories in the mole planet to support the Earth's current population for 30 billion years. Normally, when organic matter decomposes, it releases much of that energy as heat. But throughout the majority of the planet's interior, the pressure would be over 100 megapascals, which is high enough to kill all bacteria and sterilize the mole remains, leaving no microorganisms to break down the mole tissue. Closer to the surface, where the pressure would be lower, there would be another obstacle to decomposition. The interior of a mole planet would be low in oxygen. Without oxygen, the usual decomposition couldn't happen, and the only bacteria that would be able to break down the moles would be those that don't require oxygen. While inefficient, this anaerobic decomposition can unlock quite a bit of heat. If continued unchecked, it would heat the planet to a boil. But the decomposition would be self-limiting. Few bacteria can survive at temperatures above about 60 degrees Celsius, so as the temperature went up, the bacteria would die off, and the decomposition would slow. Throughout the planet, the mole bodies would gradually break down into kerogen, a mush of organic matter that would, if the planet were hotter, eventually form oil. The outer surface of the planet would radiate heat into space and freeze because the moles form a literal fur coat, and so when frozen, they would insulate the interior of the planet and slow the loss of heat to space. However, the flow of heat in the liquid interior would be dominated by convection. Plumes of hot meat and bubbles of trapped gases like methane, along with the air from the lungs of the deceased moles, would periodically rise through the mole crust and erupt volcanically from the surface, a geyser of death blasting mole bodies free of the planet. Eventually, after centuries or millennia of turmoil, the planet would calm and cool enough that it would begin to freeze all the way through. The deep interior would be under such high pressure that as it cooled, the water would crystallize out into exotic forms of ice such as Ice 3 and Ice 5, and eventually Ice 2 and Ice 9. All told, this is a pretty bleak picture. Fortunately, there's a better approach. I don't have any reliable numbers for global mole population or small mammal biomass in general, but we'll take a shot in the dark and estimate that there are at least a few dozen mice, rats, moles, and other small mammals for every human. There might be 1 billion habitable planets in our galaxy, so if we colonize them, we'd eventually bring mice and rats with us. If just 1 in 100 were populated with small mammals in numbers similar to Earth's, after a few million years, not long in evolutionary time, the total number that have ever lived would surpass Avogadro's number. So if you want a mole of moles, build yourself a spaceship. And that is the question, what would happen if we had a mole